channel Electron Chemistry tutorial. I am Vijayalaxmi. Now let us discuss quantum numbers and electronic configuration from atomic structure. So in before 3 videos we have done some important objective bits from atomic structure. If you haven't watched those videos, please watch that videos. They are really help for you. Okay. So let's get into our topic. Okay. First of all, some important points from quantum numbers. So to determine position of electron in an atom, so we need 4 quantum numbers. We require 4 quantum numbers. They are principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Okay. First of all, principal quantum number was proposed by Niels Bohr to explain the line spectrum. So it denoted by n, its values are 1, 2, 3, so on, are represented as k, l, m, n, so on respectively. Clear? So it represents at its significance the energy of the orbit, size of the orbit. And also it represents the main energy levels present in that atom per given electron. Clear? So the next, as n value increases, size and energy of the orbital. As n value increases, size, energy of that orbit also increases. So nothing but simply here this is nuclear, this is first orbit, n is equals to 1, second orbit n is equals to 2, third orbit n is equals to 3. So as n value increases, size and energy of orbit also increases. Okay, here energy is 1 only, here 3 only. So energy increases, no, size here to here distance is very, suppose 1 centimeter. So here to here 2 centimeters. Okay, assume that simply. So as an n value increases, size and energy of that orbit also increases. Nothing but the distance of electron from nucleus also increases. Clear? So the next here, the maximum number of electrons present in that main level or in that orbit is equals to 2n square. Suppose n equals to 1, so that is nothing but 2n square means 2 into 1 into square, that is equals to only 2. So nothing but n is equals to 1 means 1s orbital has only 2 electrons. Maybe n equals to 3, n equals to 3, 2n square, no, so 2 into 3 square. So how many electrons here? 9 into 2, 18 electrons. So 18 electrons means here how many? 18 electrons present in the third energy level. In third energy level, which orbitals are present here? So you will be clear here in sub levels. Okay, so I will show you here. Next here, azimuthal quantum number is proposed by Sommerfeld to explain the fine structure of atomic spectra or fine structure of spectral lines. So its value is denoted by small l, its value 0, 1, 2, 3, so on are represented as s. For 0, s orbital, 1, p orbital, 2, d orbital, f. For f orbital, l equals to 3. So up to n minus 1. Clear? So next, it represents the sublevels present in the main level. Sublevels nothing but maybe s, p, d, f sublevels. Okay. So it also significance shape of the orbital, s orbital, p orbital, d s orbital spherical, p orbital dumbbell, d orbital double dumbbell, f orbital 4 dumbbell. This already we have learnt in the previous classes. Okay. So next here, number of sublevels is equals to n, azimuthal quantum number. Number of sublevels is equals to azimuthal quantum number. Okay, so that number of sublevels is equals to azimuthal quantum number n, nothing but here, and suppose n is equals to 1, number of sublevel, that is 1, only 1 s. Okay, only 1, that is s orbital, that is equal sublevels 2. So sublevels, sorry, if n is equals to 2, sublevels are 2, they are s and p. N equals to 3, sublevels s, p, d. N equals to 4, sublevels are 4, they are s orbital, p orbital, d orbital and f orbitals. Okay. So next, number of electrons in sublevels 4l plus 2. Suppose for 2s orbital, suppose sublevels s orbital, for s orbital l equals to 0, So 4 into 0 plus 2. How many electrons? 2. For every s orbital has 2 electrons only. P orbital nothing but L is equals to, suppose I will show you here. For P orbital, L is equals to 1, L value. So 4L plus 2 means 4 into 1 into plus 2. How many electrons? 6 electrons. Means in Px 2 electrons. There are 3 generate p orbitals, no? So 1, 2, 3, 4, 5, 6. Clear? See ya. Next here. Next magnetic quantum number. So this will explain here. So don't get confused here. So next, this is proposed by Landé to explain Zeeman and Stark effect. So what is Zeeman effect? Splitting of spectral lines into group of final lines in the magnetic field. So is known as Zeeman effect. So splitting of spectral lines into group of final lines in electric field is called Stark effect. Okay. So it is denoted by M or ML. Its values are minus L plus L including 0 only. It means maybe L equals to 0, M also 0 but not more than 0. L equals to 1, M will be minus 1 or plus 1 and 0. So not more than 1. Okay. L equals to maybe 2, M values are plus or minus 2, plus or minus 1, 0. Okay. So not more than 2. Clear? So if L is equals to 3, so plus or minus 3, plus or minus 2, plus or minus 1 including 0. Including 0. So not more than 3. Okay. It represents the orientation of orbitals in this space. It represents sub levels in main levels. Sub levels, main levels, nothing but number of sub levels means orbitals is equals to n square. Okay. Sub levels is equals to n. Sub levels is equals to n square. Means suppose for example here n equals to maybe 1. Sub levels is equals to n only. So means 1, that is maybe s orbital. 1 means only s orbital. So s orbital means sub level means so that 1 s orbital that is only 1 s orbital. Okay. So maybe here don't get confused, listen to me carefully here. N is equals to 2. Sub level is equals to n, no? So nothing but sub levels are 2. There what are sub levels? Sub levels nothing but orbitals. So means n square means 2 square. So they are 4. Nothing but in second energy level 2s orbital. 2p means 2px, 2py, 2pz. 1, 2, 3, 4. 4, no? Clear? So now here n equals to 3 means number of electrons. I will show you number of electrons also here. So number of electrons in n is equals to 3 orbit. Means the number of electrons is equals to formula 2n square, no? So n equals to 3, nothing but 2 into 3 square, that is 18 electrons. So to fill that 18 electrons, the number of electrons in third orbit means in third orbit sublevels are 3. Sublevels are 3, they are 3s, 3p, 3d. Okay. Sublevels means orbitals. How many orbitals are possible here? So for 3s, 3s only. For 3p, 3px, 3py, 3pz. So for d orbitals 5, no? 3dxy, 3dyz, 3dxz, 3x square y square, 3dz square. Okay. So here how many orbitals here? 1, 2, 3, 4 and 5. So how many orbitals? 9 orbital. Each orbital can filled with 2 electrons, no? Okay. So each orbital filled with 2 electrons. So 9 into 2. How many electrons? 18 electrons. Clear? Clear everybody? Next Here, spin quantum number. It was introduced by Uhlenbeck and Goudsmit. So it is denoted by MSR or simply S. Its values are plus half and minus half. So it represents the spin of the electron in an orbital. Okay. So maybe upward direction or clockwise direction it shows plus half. Downward direction, anti-clockwise direction shows minus half. Clear? So this is what quantum numbers. Clear? Next, electronic configuration. How to define simply? The distribution and arrangement of electron in main levels, sublevels and sub-sublevels in atom of that element is known as simply electronic configuration. Clear? So this electronic configuration, while filling the electrons in an orbital of that atom, you can follow the NLX method, orbital diagram method. NLX method nothing but N is principal quantum number may be 1, the L means maybe 0 for S orbital, 1 S, maybe 1 electron, 1 S 1. So it's the most useful method, easily understandable method. So orbital diagram method, maybe one orbital is there, one electron, then another electrons, maybe degenerate orbitals are there. One electron filled first, then only pairing will take place according to Hund's rule. While filling the electrons in an orbital, so we should follow the 3 rules above principle. Pauli's exclusive principle, and Hund's rule of maximum multiplicity. Okay, so we have to follow these rules, then only we will get a correct electronic configuration. So first of all, above principle. So above principle, filling of electrons in an orbital in increasing of their energies. Okay, the energy of orbitals can be calculated by n plus L value, can be represented by n plus L value. Okay, suppose for example maybe 1s orbital, 2s orbital both are present. So which is filled first? N value for n is equals to 1 here, L equals to 0. For 2s orbital n equals to 2, L equals to 0. So then next here for n plus L value for 1s orbital, 1 plus 0 equals to 1, here 2 plus 0 equals to 2. So which is filled first? Which has the least n plus L value, that is filled first. So 1s is filled first, then only electron enter into the 2s orbital. Clear? Next, if some orbitals have same n plus L value, suppose for example 3d orbital 4p 5s, 3 plus 2 L value for d orbital 5, 4 plus 1 p orbitals L value 1, so 5, s orbital 0, so this 3d 4p 5s orbitals all are have same n plus L value. So in these cases which has the least principal quantum number, that is filled first. So then only electron enter into the next highest principal quantum number of that element. Next 5s. Clear? So this energy of increasing order of their energy of orbitals can be remembered with the help of the Euler's diagram. So 1s orbital filled first, then all electrons enter into the 2s, then 2p 3s, 3p 4s, 3d 4p 5s, then 4d 5p 6s, 4f 5d 6p 7s. Okay, so this is order for the filling the electrons in increasing their energy levels, increasing their energy of orbitals. Okay, next Pauli's exclusive principle. So according to Pauli's, no two electrons, suppose for example 1s2 electron, no two electrons in an orbital of that atom have same set of 4 quantum numbers, there is a difference in at least spin quantum number. So here 1s 2 electron, this is first electron, second electron. For first electron n value 1, second electron also n value 1, L equals to 0, L also 0, M equals to 0, M also 0. For s orbital L value 0, M also 0. But for first electron, for upward direction plus half spin quantum number, for downward direction minus half. Okay, so there is a difference in at least spin quantum number. No two electrons have same set of 4 quantum numbers, same set of all 4 quantum numbers in an orbital of that atom of the element. Okay, next Hund's rule of maximum multiplicity. Okay. So here suppose for example oxygen, you can take 8 atomic number, 1s2, 2s2, 2p4. Okay. So here 1s2, only one orbital, after filling one electron, second electron will be paired. So here also same, but for the p orbital this is px, py, pz. So while filling degenerate orbital, each orbital filled one electron each, then only pairing will take place according to Hund's rule. So this is the right way, but suppose for example 4 electron 1, 2, 3, 4, this is empty, not this way is wrong. Okay. So each orbital filled with one electron each, then only pairing will take place. So that is Hund's maximum multiplicity. Next, stability of atom. Okay. So atom's stability depends on the electronic configuration. So atoms with half filled or completely filled electronic configuration in those orbits, they are only stable when compared with incomplete electronic configuration. Okay. So here, so this suppose for example you can take nitrogen and oxygen. So 7 atomic number, that is 1s2, 2s2, 2p3. Next here 1s2, 2s2, 2p4. So 2p3 nothing but here for nitrogen half filled configuration is there. Each orbital filled with one electron, half filled configuration. Due to this half filled configuration, nitrogen atom is more stable when compared with the oxygen. Okay, because of oxygen incompletely filled configuration. Here by half filled completely filled electronic configuration, that atom will get extra exchange energy. So that's why they are stable. How to calculate that extra exchange energy? N into n minus 1 into k by 2, k is constant simply. N means number of parallel spin electrons, upward direction or downward direction, number of parallel spin electrons. Suppose for example here chromium, we know very well atomic number 24. How to write configuration? Argon 4s1 3d5. Actually this is stable configuration. Actually we will expect 4s2 after filling the s orbital only electron enters into the d, no? So 4d 4s2 3d4 actually. But in this configuration, how many parallel spin electrons? Here 4s2 upward direction, remaining electrons 1, 2, 3, 4. Fifth orbital is empty. Upward direction parallel spin electrons. How many parallel spin electrons? 5. 5 into 5 minus 1 by 2 means how much? 20 by 2 means 10k. But here parallel spin electrons, here this electron can excited to here. Okay. How many parallel spin electrons now? 6. 6 into 6 minus 1 by 2 means 30 by 2 is equals to 15. So which has more exchange energy, that will be more stable. So that's why in this configuration chromium is more stable. That's why we will write this as anomalous electronic configuration for chromium. Clear? So this is the stability of atom. Next finally, so last topic, isoelectronic species. Atom, group of atoms or ions have same electrons, they are called simply isoelectronic species. Suppose for example neon has 10 electrons, maybe sodium has 11 electrons actually, but loss of 1 electron has 10 electrons only. Magnesium actually 12 electrons, by loss of 2 electrons 10 electrons. So maybe nitrogen has only 7 electrons, by taking 3 electrons it has 10 electrons. Oxygen has only 8 electrons, by taking 2 electrons it is also has 10 electrons. F minus also has 10 electrons. So simply the group of atoms or ions with the same electronic configuration or same number of electrons is known as simply isoelectronic species. Clear? Let's do some objective bits on quantum numbers and electronic configuration. Let's start. First problem on quantum numbers. Which of the following set of quantum numbers is correct? An electron in 3D orbital. So this is previously MSET 2015, AP MSET 2015. Okay. So first you have to write 3D orbital, N value, L value for here for 3D orbital. What is n? Equals to 3. For d orbital, L equals to 2. L2 means m may be plus or minus 2, plus or minus 1, 0 only, but not more than 2. Then S may be plus half or minus half. You can take any one. You can select that one. So here n equals to 3, L okay, but m is more than L value is wrong. Here also m value more than L value wrong. So he is similar to, okay. So this m equals to minus 2. Okay, we have to select this one. Because here m values are more than the L values. That is impossible set. Okay. So which is correct set? So m L equals to 3, L equals to 2, m equals to minus 2, s equals to plus half. Clear? Next. If the value of principal quantum number n equals to 3, the total possible values for magnetic quantum number. What you get simply here, the magnetic quantum number, m value is nothing but number of sub levels. Sub levels or simply orbitals. Each m value has one orbital, no? Okay. So simply number of sub levels in that orbit is equals to what? N square only. So that is equals to 3 square means n. So n means what? Simply here. So simply have to select n, or you can do like this. You can calculate another way. So n equals to 3 nothing but sub levels. Sub levels nothing but 3 only. They are 3s, 3p, 3d. Okay. For 3s, 1s orbit, 3s means 1 orbital, means m equals to 0. So 3p. So the m may be minus 1 plus 1, 0. Okay. 3d have 5 degenerate orbitals. 1, 2, 3, 4, 5. Minus 2, minus 1, 0, 1, 2. So now calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear everybody? So simply have to calculate number of m value is nothing but number of sub levels means orbital, that is equals to square n square, 3 square nothing but 9, or sub levels is equals to principal quantum number 3 only. So they are 3s orbital, 3p orbital, 3d orbital. Okay. So for s orbital m value 0 only, p orbital minus 1 plus 1, 0. So d orbitals 5 values. So total 9 values. Clear everybody? Next. See a third problem. This is also previous bit MSET 2016 TS Telangana state. Total number of orbitals associated with principal quantum number n is equals to 4. Total number of orbitals means sub levels. Sub levels or orbitals is equals to n square. N value is given as 4 squares. There are 16 orbitals. And now, suppose you want to know what are the orbitals. 16 orbitals means simply here. So that is 4th energy level, no? 4s orbital, 4p orbital, 4d orbital, 4f orbital. 4s only one orbital, 4p px, py, pz. Okay. Next d orbitals are 5. dxy, dyz, dx square, y square to dz square. Okay, 5 orbitals. F orbitals we know very well, 7 degenerate orbital. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So 1, 3, 4 plus 5, 9 plus 7. How much? 9 plus 7, 16 orbitals. Clear? You have to know like this. So otherwise simply n square is equals to 16 orbital, enough. Okay. Next question also previous TS 2015. An element in +2 oxidation state, listen to me carefully. An element in +2 oxidation state has 24 electrons. the atomic number of that element and the number of unpaired electrons in it respectively. See here, suppose that element M in +2 state has 24 electrons. Means by loss of 2 electrons, it has 24 electrons. Means atomic number nothing but, how to find out atomic number? Atomic number is equals to number of protons in that nucleus and number of electrons in neutral atom. Means 24 plus by loss of electrons. So actually electrons are 26. By loss of its 2 electrons, it has 24 electrons. Means atomic number 26. What is the element? Iron +2. Write down configuration: argon 4s2 3d. Actual configuration 4s2 3d 6. By loss of 2 electrons. By loss of 2 electrons, 4s0. Okay. So then 4s0 empty, but 3d 6. 1 2 3 1 2 3 4 5 1 2 3 4 5 6 electrons will be paired. How many unpaired electrons here? Without pairing, 4 electrons. Okay. So atomic number of that element 26 and how many unpaired electrons? 4 respectively. You have to select this option, 26 minus 4. Clear? Next. How many electrons can fit in the orbital for which n equals to 3, L equals to 1. N equals to 3 means 3, L equals to 1 means 3p orbital. Okay. How many electrons fit in the orbital? The orbital means only single orbital, maybe px orbital or maybe py orbital or pz orbital. Each orbital can fill it with only 2 electrons. 2 electrons simply. This is also previous bit, NEET 2015. Clear? So in the orbital means only one orbital. One orbital can fill it with only 2 electrons. Clear? Next, how many electrons maximum can have n plus L value is equals to 4. N plus L value is equals to 4 possible for only 2 orbitals. They are 4s orbital and 3p orbital. How? See here, for 4s 4, n value 4, for s orbital 0, that is 4 only. So this is what 4s orbital. So for 3p orbital 3 plus for p orbital L value 1, 4. So this is what 3p orbital. Okay. For 4s orbital, any s orbital have only 2 electrons because of it has only one orbital. 3p, 4p, 2p, whatever it is, p orbitals are 3, each orbital can fill it with 2 electrons. Here 2 electrons, here 6 electrons. Okay. The maximum number of electrons can fill it with, can have n plus L value 4. How many electrons? 2 plus 6, 8 electrons. Clear? Next, 7th problem. The number of sublevels in the quantum levels n equals to 3. Number of sublevels nothing but n equals to n, nothing but 3 only. So what are they? 3s, 3p, 3d only. So number of sublevels n equals to 3, 3 only. So they are 3s orbital, 3p orbital, 3d orbital. Clear? The next. So which one of the following ion has same number of unpaired electrons as those present in vanadium plus 3 ion? So first of all you have to write vanadium plus 3 electronic configuration. So vanadium actually 23, argon 4s2, 3d3. Okay. So by loss of 3 electrons, nothing but 4s0, 3d2. 3d2. Okay. So means 4s0 empty, 3d orbital has 2 electrons, 1, 2, 3, 4. 5 orbitals have only 2 electrons. These 2 electrons are 2 unpaired electrons. These are unpaired electrons, not pairing electrons. Okay. Now it means vanadium plus 3 ion has 2 unpaired electrons. So in which of the following has 2 2 unpaired electrons. We have to calculate. We have to find out. Okay. So Fe plus 3 means so atomic number 26. How to write configuration argon 4s 2 3d6 for neutral atom. But plus 3 means loss of these 4s electrons and 1 d electron. Means how many unpaired electrons here? 5. 1, 2, 3, 4, 5. D5 no? 5 unpaired electrons. So this is not matched with vanadium. Next nickel. Nickel 28. So write down configuration argon 4s nickel plus 2 means loss its s electrons 4s 0 3d8. So 3d8 means d orbital have 5 degenerate orbital, each orbital filled with 1 electron each, then only pairing will take place. 6th electron, 7th electron, 8th electron. How many electrons? 2 unpaired electrons. Simply we got the answer. Suppose if you want find out for this unpaired electrons also, write electronic configuration 25 atomic number by loss of 2 electron means 4s 0 3d 5. So it has 5 unpaired electrons like this. Okay, unpaired electrons. Next chromium 24 only, argon 4s 0 4s 1 3d 5 no, 4s 0 3d 3 means 3 unpaired electrons. So only nickel plus 2 have same 2 unpaired electrons with vanadium plus 3. You have to select nickel plus 2. Clear? Next. So this is previous bit AP MSET 2015. What are the total number of orbitals and electrons for m equals to 0? If there are 30 protons in an atom. 30 protons in an atom, atomic number 30, nothing but write down electronic configuration, that is simply zinc. So write down zinc electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay. 2 plus 2 4 electrons, 10 electrons, 12, 18, 20, 30. Clear? So m equals to 0, nothing but for s orbitals 0, m equals to 0, and for p orbitals and d orbitals 1 orbital with m equals to 0. For p orbitals and d orbitals, in those degenerate orbital, 1 orbital with m equals to 0. Okay. So it means simply here 2p has 1 orbital with m equals to 0. 3p orbital has 1 orbital with m equals to 0. 3d also has 1 electron. Means so see here simply 1 s orbital. How many s orbital? 1 s orbital, 2s orbital, 3s orbital, 4s orbitals. Okay, for these orbitals m equals to 0. Enough. Next 2p orbital 6 electrons, but 2px, 2py, 2pz no. So for z orbitals m equals to 0. This is what m equals to 0 first. Okay. Next 3p also same, 1 orbital with m equals to 0, minus 1 plus 1 0. So you have to select this m equals to 0. Next 3p over, then 3d. 3d orbital has 5 degenerate orbital, in that 1 orbital with m equals to 0. M equals to 0. Clear? So here S orbital filled with 2 electrons. Now how many orbitals? 1, 2, 3, 4, 5, 6, 7. Simply total number of orbitals with m equals to 0. How many orbitals? 7 orbitals. Each orbital filled with 2 electrons. So 14 electrons. Clear? Next. Among the following isoelectronic species. Isoelectronic species nothing but this is also previously 2016 TSM set. Okay. Isoelectron species nothing but that a group of atoms or ions have same number of electrons or same electronic configuration. Clear? You have to select. O minus 2 means oxygen actually has 8 electrons. By gaining of 2 electrons, 8 plus 2, 10 electrons. Fluorine 9 electron, by gaining of 1 electron, it is also has 10 electrons. Sodium actually 11 electrons, loss of 1 electron. Here place means loss of 1 electron, 10 electrons. So magnesium also have 10 electron, means 12 electrons. In that 2 electrons are lost by magnesium. All are have 10 electrons, so they are isoelectronic species. Now for this 10 electrons, aluminium actually 13, by gaining up another 3 electrons, 16 electrons. So 10, 16 means this is not isoelectronic species. Next, n minus 3, 7 plus 3, 10 electrons, neon also 10 electrons. So 1 and 3 options with the same electron, isoelectronic species. Clear? Next, 11th problem. This is also previous bit, recent bit, JEE Mains 2021. Number of orbitals with n equals to 5, m equals to plus 2. Listen to me. N equals to 5, nothing but how many possible orbitals? 5s orbital, 5p orbital, 5d orbital, 5f orbital and 5g also possible. Okay. Now for 5s orbital m equals to 0. For pi p orbital m equals to minus 1, 0, plus 1. For 5d orbitals m equals to minus 2, minus 1, 0, 1, 2, plus 1, plus 2. For 5f orbitals m equals to minus 3, minus 1, m values minus 3, minus 2, minus 1, 0, 1, plus 1, plus 2, plus 3. Next 5g orbitals. For 5g orbital m value, L value 4 no, means m equals to minus 4, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, plus 4. Okay. Now listen. Number of orbitals with n equals to 5, actually 1, 2, 3, 4, 5 orbitals. But especially m equals to plus 2 only. Here for s orbital there is no m equals to plus 2. For p orbital also. But 5d orbital has 1 orbital with plus 2, m equals to plus 2 value. For 5f orbital with 1 orbital plus 2 value. 5g orbital also has 1 orbital with plus 2. So n equals to 5, m equals to plus 2 values of orbitals. How many orbitals? 1, 2, 3 only. 3 orbitals with n equals to 5, m equals to plus 2 only. You have to select 3. Clear? Now, delta, this is also previous bit. The quantum numbers of 4 electrons given below. So this is for first electron, second, third, fourth, whatever it is. So n equals to 4, L equals to 2, m equals to minus 2, s equals to minus half means which orbital? 4, L equals to 2 means 4d orbital. Clear? N equals to 3 means 3d orbital. L equals to 2 means for d orbitals only L equals to 2. Azimuthal quantum number. Now 4 L equals to 1 means p orbital. Now n equals to 3, p orbital, order of their increasing energy will be. How to find out order of increasing energies? By n plus L value. N plus L value. Okay. For 4d orbital, n plus L value 4 plus 2. How much? 6. Next 3d orbital, 3 plus 2, 5. Next 4p orbital, 4 plus 1, 5. Next 3p orbital, 3 plus 1, 4. So which has the least n plus L value? 4 means 3p. 3p is the least energy level, 3p is less than that of. Next 5. For both 3d, 4p orbitals, n plus L value 5. So which will come first? Which has the least n plus L value? That will come first. 3d. Next 4p. Next what? 4d. Okay. So 3p orbital given in 4th electron less than that of 3d second less than that of 4p third less than that of 1. So this is the order, increasing order of energies. Clear? Next problem. The correct set of 4 quantum numbers for valency electron of rubidium atom. So atomic number of rubidium given as 37. So rubidium 37, write down configuration krypton 36 over, then 5s1. 5s1 only. So this valency electron, write down 4 quantum numbers, n equals to 5. For s orbital, L equals to 0, m also 0. S spin quantum number only 1 electron plus half. So these are 4 quantum numbers for valency electron of rubidium atom. Clear? That's all friends. You have to practice some more bits from atomic structure. While doing practice, if you get any queries, please put a message on the chat box. We will discuss that queries in the next video. Clear? So did you like this video? Please like, share this video and subscribe my channel to get more videos. Thank you for watching this video. Thanks a lot.